Hey, welcome back to the Systems of Equations notes. This is page 4 and probably page 5, maybe page 6, we'll see. Example 5, solving a system with infinitely many solutions. So again, I have a system of two equations with two unknowns. I want to be able to cancel one of the variables. So I notice that my x's are opposite. I got a positive 8x, I got a negative 4y. I can multiply this second equation by 2, and it gives me a negative 8x plus 2y equals 4, and I am just going to repeat the top equation. And color code so we don't get confused here. I got positive 8x minus 2y equals negative 4. When I add straight down to eliminate my x's, I get 8x minus 8x, that's a 0. I've got negative 2y plus 2y, that is also a 0. And I got negative 4 plus 4, which is 0. I get 0 equals 0, which is always true. So there are infinitely many solutions. It means any x and y I plug in that makes one equation true is going to make the other one true. So let's take a look at an application problem. I know we've been trained from middle school on to be super scared every time we talk about word problems. The thing is that's how the real world works. Okay? So we are going to solve an application problem, an applied problem, by writing a system of equations. Step 1 is to read the problem carefully. What information is given? What do we need to find? Step 2, we've got to assign variables, and we want to make sure we are specific and label them. Sometimes a sketch or diagram helps. Step 3, we're going to create the equations that relates the unknown variables. We're going to solve the system of equations. And then we're going to state our solution. We want to make sure it seems reasonable. And that we have labels. And then we are going to state the answer in the words of the original problem. So let's see what we got here. Example 5, we are using a linear system to solve an application. We want to find salaries. So salaries for the same position can vary depending on the location. In 2019, the average of the median salaries, median is the salary in the middle, so not the highest, not the lowest. If we organize everything smallest to largest, one in the middle, for the position of accountant 1 in San Diego, California, and Salt Lake City, Utah. That average was $53,763.50. The median salary in San Diego, however, exceeded the salary in Salt Lake City by $6,733. We want the median salary for the accountant 1 position in San Diego and in Salt Lake City. So the first thing I'm going to do is label, and I'm going to be specific, median salary in San Diego. I'm not just going to call it San Diego. The variable can't represent a whole city. And we have to be specific about what we're talking about, because it's really easy to get that confused sometimes. And Y is going to be our median salary in Salt Lake City. Okay. They tell me that the average of the median salaries, average means I'm going to add these two together and divide by 2. I'm adding two things, I divide by 2. The average is $53,763.50. I also know that the San Diego salary is the Salt Lake salary plus 6,733. It exceeded the Salt Lake City salary. Okay. So before I plug in over here, I am going to start by multiplying both sides of this equation by 2. The 2's cancel here. I get x plus y equals 107,527. I cannot solve why I have 2 variables, but I do have this fabulous second equation where x is already solved. So I'm going to go ahead and I'm going to plug in y plus 6,733 for my x. What this does is give me an equation in just one variable. I'm going to subtract 6,733 from both sides. Divide by 2. Keep in mind this is $1. Y equals $50,397. So that's our salary in Salt Lake City. X is 50,397 plus that 6,733. $57,130. Okay. Median salary in San Diego is 57,130. You want to be careful, make sure you're stating it correctly. In Salt Lake City, it's 50,397. Let's not get that confused with another number. There we go, pages 3 and 4 and 5. 4 and 5.